Hey guys, welcome back. This is episode 9 of my dev diaries. You will know what we're doing here by now. If you don't, go back to the start, you'll be pretty confused. We are building a VR exposure therapy system still. The last update I put out, episode 8, ended up being like 40 minutes long. So the plan going forward is to try and do these updates with a bit less content each time, but hopefully more regularly, because 40 minutes is a long time to listen to me ramble. So today, what we're going to be talking through is some refactors to the architecture that basically governs all of our spiders. Now, it's not particularly glamorous work, but it is super, super important. It doesn't add any new functionality, but it will basically enable us to add new functionality going forward. The current state of the architecture, or the previous state now that it's all been changed, was a complete mess, which makes it really hard to add anything new. When you do, you introduce loads of bugs without knowing why. It's really hard to track down those bugs. It's hard to track down existing bugs that were already there previously. And it just makes it impossible to work out what on earth is going on, which was definitely the state of the system before this last batch of work. So super, super important stuff. Nothing glamorous like new features, but hopefully it's at least a little bit interesting. It's interesting to me, but maybe that's just because I'm a massive nerd, who knows. So, the architecture for the spiders has been a mess for a while. To clarify, this isn't the sort of overall system architecture, this is just the architecture that fits all of our spider classes together. It's not just like every spider has just one single script, and that does everything spider related. It's too complicated for that, so we need different scripts to separate everything out. So yeah, it's been a mess for a while, and I've kind of lived with it, but it's sort of come to a head now that we've started adding these new spider models that we talked about in the last update. Now that we have that sort of extra layer of complexity, it's just making it impossible to do anything, hence this big refactor. So I'm going to start off walking you through the existing architecture, and hopefully you'll start to get a grip of why it's been such a pain to do anything with this. So this is like a pseudo UML diagram, I guess. I've got the associations in here, but I haven't gone into the detail of, the accessibility levels of each property and behavior on each class, stuff like that. But this should give you a decent idea of what's going on. So to give some context for anyone that isn't familiar with these, so hollow diamond here is aggregation. So this means that the thing on the diamond end can have the thing on the tail end, but doesn't necessarily have to. So say, for example, the spider game object can have a spider manager, but doesn't necessarily need to. That sentence already doesn't sound right? Like that should be a good indication already that stuff isn't quite right here. Opaque diamond is composition, which means that we have to have these things. So a spider manager has to have a spider animator. Sorry. Think of it like, a car has to have wheels. Intrinsically, that's what makes it a car. But a car doesn't have to have a radio. It can have a radio, and usually they do have radios, but not necessarily. So for example here, this hollow diamond, the spider game object doesn't have to have any one of these in particular, but it has to have at least one of them. It's this little one-to-one thing here. What else do we have? This, okay. When I've put something in this like diamond shape, it means that this class is abstract. So we can't ever have an instance of just spider animator. It has to exist as either wolf spider animator, tarantula animator, or jumping spider animator. So you can't just have a spider animator without any like flavor to it, I guess. And an arrow like this means inheritance. So a tarantula animator is a spider animator and will inherit all of the properties and behaviors on this class. Cool. So let's start with these. So these are the controllers for the spiders that I talked about last episode. So we have a controller for the spider that sits in the tank and reaches up for the food. We have a controller for the spider that follows your laser pointer on the table. We have a controller for the spider that traces out a shape on the table. And we have a controller for the spiders that walk around the table randomly, which is the ones that you saw at the beginning, which is these guys. So this spider manager class here only has the random path controller class, and that's because its functionality is currently only relevant to the random pathing spiders. So it does two things. The first of those things is that it handles the scale of the spider. So if we look at the different ones here, this tarantula is smaller than this tarantula, and the code has to know that so that when we trigger the animations, this walk animation, it plays the animation on the bigger spider slower, and it plays the animation on the smaller spider faster, so that its legs are moving faster to cover more ground because it's smaller, right? The second thing it does is handle the grabbing of our spider. So if we grab it and pick it up, then the pathing should basically stop. We don't want it to keep on walking around, or it's going to start flying around everywhere like crazy. So that's why the spider manager has only the random path controller spider. It doesn't really make a whole lot of sense to be storing both of those pieces of functionality in the same class. Doing it that way means that if a spider has that, scale change thing going on, then it has to also be grabbable, which is a weird constraint to impose. It means that we can't have a spider say that, we can grab but that never changes scale, or that does change scale but we can't grab. That wouldn't be an option under this current architecture that we have here. So the thing with this architecture, aside from, this spider animator here, basically everything has direct access to this animator. When you have loads of classes that directly have access to the same class, that's often a bit of a red flag. So yeah, that's not really right. All of these controllers all have access to this animator, which means that they could be basically underneath a parent abstract superclass that itself just has access to this animator. And we wouldn't need all of these arrows here. I'll show you what that looks like in a minute. So let's take a look at an example of how this kind of an architecture can make the actual code itself difficult to work with. So let's take, for example, the controller that manages the spider that walks in a shape around the table. So if we want to do basically what we just said, and we want to have this spider have a different scale than normal, so say, I don't know, at the start of the level, we randomize the scale on this spider, or we have the spider change its scale every time the number of the round changes. So every time you say, circle, square, triangle, and it progresses to the next round, we say grow our spider by a factor of 1.2 or something. So the way that the scale functionality basically already works is that we have a bunch of these little sneaky game objects under the table. Now these are our default scales for each model of spider. So say this one is called, if we can find it in the hierarchy here, default wolf spider, default tarantula, default jumping spider. So what the spider manager, does is it checks which kind of spider model we are, and then it finds that game object under the table according to which spider we are, and then uses that scale versus the scale on the object of the script we are attached to work out what our sort of scale multiplier is. And then it sends that off to the path controller so that knows what our scale is, so that the path controller can then tell the animator what our scale is, so that the animations work properly. So if we wanted that to work with the spider shape path controller, then we would need to either copy that whole functionality so that when we set the walk animation, is this the right file? No, it's not. Let's have a look in the actual right file. So when we set the walk animation here, then we can pass in the scale multiplier so that we animate properly. Or if we don't want to copy and paste it into this file and we want to reuse the existing code, then what we could do is we could have the spider manager also hold a reference to the shape path controller, and like we are for the random path controller here, we can have a function that lets us pass in the scale multiplier and then do it that way. The issue with that, because that now causes more problems, is that this means that the spider manager, or each spider game object, will only have one version of this controller, right? It won't have both a spider path controller and a random path controller. So if we add both of those things in here, we have to have another check that works out which one of those components we have and only calls this setup scale multiplier on the right one. Otherwise, it will call it on a null class, and then we'll get a null reference exception. Another issue we'd have is that now that we have the spider manager being associated with the shape path controller, is now we've added the functionality for that spider on the table to be able to be picked up, which we might not necessarily need to do, and that might cause a bunch of unintended bugs. Obviously, most bugs are unintended. A bunch of unintended behaviors, and that can cause bugs on that spider. So all around, it's a bit of a mess to actually add anything. Something else that is difficult with all of this is that let's say we want just this tarantula, or just the tarantula type of spider, to move slower or faster than the other spiders. To do that, it means that we have to have that path controller know what type of spider model we are, which it shouldn't really have to do. The pathing controller shouldn't really have to have any kind of an understanding of the model on the spider. They should kind of just be concerned with pathing, and that's it. But if we wanted this spider path controller to make the spider move faster if it's a jumping spider or a wolf spider, we would need functionality in here that works out what kind of spider it is, and then we'd need 3 different sets of movement speeds. So this base speed here would have to define it 3 times for each kind of spider, and then basically reference the correct speed according to what model we are. And we'd have to do that for each of these controllers that we want that functionality in. Or we could move that to the spider manager, but that then has the same problems that we were just discussing with adding the grab functionality and potentially causing null reference exceptions. So hopefully that does some kind of a job at illustrating how the worse your architecture is, the more code you have to write to circumvent the problems of how you put it all together. And the more code you have to write, the more difficult it is to maintain it all, harder it is to add new stuff, to fix bugs, and just to work out what's going on. The only good thing about this architecture really is the way that we have this spider animator done. So again, this spider animator is an abstract class, and it has 3 flavors. So wolf spider animator, tarantula animator, and jump spider animator. Because each different animator has like some different quirks on how to actually execute the animations. Now that means that, say, random path controller doesn't have to know what kind of animator we are. It just calls whatever abstract functionality on the spider animator class itself, and then that basically propagates through to whatever flavor of animator we are. So according to this, we shouldn't have to know what type of spider we are, but thanks to everything else that's also going on, if we wanted to have different spiders move at different speeds, which isn't just about the animation, it's also about actually moving laterally in the scene, then we would have to know what kind of spider we are. But yeah, the general approach of this animator works. We just have to do the same thing with more stuff. So let's look at the new architecture that we have. Okay, So the left side is old, right side is new. The right side looks more complicated. I promise you it's not, okay? I think it looks more complicated because we have this new spider constants thing going on. So what this is basically doing is that, like we were just saying, if we wanted, say, the tarantula to have a different base movement speed, then we can just define it in this tarantula constants class. So each game object has attached to it a different flavor of this spider constants class. And if it's a tarantula, we attach the tarantula constants, and that has our new different walking speed in it. And then the random path controller wouldn't have to know what type of spider we are, because it just references that walk speed value through the abstract spider constants class, if that makes sense. The next thing we've changed is we've separated out the spider manager class into two classes. So we have spider grab controller and spider manager. So spider manager is just the new name for that second component rather than the exact same component as it was before. So spider manager, the new version, is going to be the parent class to each of these different types of spider controllers. So that means that regardless of if we're a tank spider controller, a follow spider controller, etc., all of these are a spider manager, which means they all have access to the spider constants class that is on the spider and the spider animator that's on the spider, without having to know what kind of spider we are. So that means that now all of these classes look a lot tidier because we haven't got to directly be referencing, say, the animator, for example, because our parent class can do that for us. The second component which I talked about was the spider grab controller. So this is basically just what, as I said before, manages when you pick up the spider and turns off the pathing on whatever pathing script we have. So the spider game object has to have an animator, it has to have a spider constants file, and it has to have a spider manager, which is one of these. It doesn't have to have a grab controller, but if it does have a grab controller, then that grab controller has to have the spider manager so that when we are being grabbed, then we can turn off movement basically and override all of that functionality. So that basically means that we've separated out the grabbing from the scaling. The scaling does live in the spider manager, which means that all of these classes have access to that scaling. They might not all need it, but if the scale was just what it would be normally, then that's just set to 1 as the multiplier and doesn't actually have any effect on the behavior of the spider, which is what we'd want in that case. So let's take an example of how this looks in the code. Let's say we want our tarantulas to walk, say, 1/3 of the speed of our other two kinds of spider. So what we do is we just go to the appropriate flavor of our spider constants class, so that would be tarantula constants, and we change this to, say, 1/3 of what it was before. And because the tarantulas, that compile, because the tarantulas all have, where are we? All have the tarantula constants class attached, as opposed to, say, wolf spider constants, it will be using that value that we just changed. So we should be able to see here that they're all walking at a slower speed and they're still animating properly. They're not animating at the previous speed, they just were. And that's because in our random path spider controller script, when we're saying set the walk animation, we are setting the speed of the animation, or passing in the speed. The animator has to know how fast we're walking to get the animation rate. We're passing in just spider specific constants dot base walk speed, which was the value that we just changed. But because we're referencing just the abstract class, we haven't actually got to know what kind of spider model we are, because it just depends on which flavor of that spider constants class we attach onto our spider game object. Another advantage of having all of these controllers be children of the spider manager is that it means when we have functionality that all of these should have, we can just put it in there. So for example, previously we had basically the same function that would take in a target as a vector 3 and basically rotate our spider towards that target at the speed that we pass in. And this was pretty much the same between the spider shape path controller, the random spider path controller, and the follow spider shape controller, which is the one that follows the cursor on the table. Some of them are a bit different. Some of them take a direction to turn to, and some of them take a target to turn towards. But the logic is pretty much the same, so we can just generalize that, and that's what we've done in Spider Manager. So where are we? This now just has this turn to target direction method, which all of the spider controllers will inherit, so we haven't got to define this whole thing 3 times. And yeah, same deal, it just takes in a target direction, takes in a speed multiplier, and then uses the turn on the spot speed from the spider specific constants. That is a tongue twister and a half, isn't it? The spider specific constants file that we have attached to our game object, and then turns it according to that speed multiplied by whatever multiplier we decide to pass in. So yeah, that means we haven't got to define this same bit of code 3 times. So yeah, with this newer architecture, we have to change things in hopefully just one place. If you want to change the speed, we just change the speed in that constants file. We haven't got to also change the animation speed manually. It should all account for that automatically, which is good. Something else that's changed is the red-blue manager. So if you remember back to the level where you have a bunch of spiders on the table and you have to pick them up and see if they're red or blue on the underneath of them and then put them in the right box. All this does is basically randomize if we are red or blue and makes accessible to the other classes in the level that might need it that aren't shown in this diagram, if we are red or blue, so that we handle the scoring properly. So if we are a spider game object that exists in that level, then we basically have this red-blue manager component. So because there's no actual pathing going on in this red-blue manager, it might seem strange that I've made it inherit from the random path controller. So how this works is that let's say we're the level where you just have a bunch of spiders on the table running around randomly, and we have to look at the ceiling and do that memory game that I talked about last episode. So we haven't got to actually pick these ones up and see if they're red or blue, because red or blue doesn't apply to them. Then we just have the random path controller. But if we have the level where red-blue does apply, then rather than a random path controller, we have the red-blue controller, which does inherit all of that random pathing functionality. The reason that I've done it that way, rather than having this just be another component that we can just tack onto the game object directly, is that it would be good if we have at least the option of allowing this type of spider controller to override the pathing behavior. It doesn't do it right now, but I might want to in the future. So, for example, if, say, we want the spiders to start moving faster or path differently when there are less spiders on the table, so as that level progresses, we put the spiders in the boxes and they disappear. So say the more spiders that disappear, the more erratically they start pathing, stuff like that. This gives us the option of doing that in a clean way. So to show you guys how this all fits in with the wider architecture of the system, so this top bit up here is basically what I talked about in episode 4 of this Dev Diary series. It's the same diagram basically, but just in a different format. I'm not showing what each different function does and stuff. I'm just giving a general idea of what the associations are. So let's say it's the red-blue level. So the spider zone manager is basically what's attached to the red box, and the blue box. So let's say we're level 9, and the Spider Zone Manager has just detected that we've dropped one of the spiders into the boxes. So Spider Zone Manager has access to level 9, and level 9 has access to the spider. So the spider will have a spider manager, and that spider manager will be a random path controller, and that random path controller will be a red-blue spider controller. So the red-blue spider controller tells us if we are red or blue. So that means that Spider Zone Manager has that information, and it then compares what color zone we are and what color the spider is. Let's say it's correct, so we tell the level 9, that's the correct answer. Let's say that was the last spider on the table, so that means that level 9 should now trigger the end of that level. So level 9 is a level manager, and the level manager has a UI manager. So that then triggers the end of level text on that UI manager. The UI manager, once we've submitted the UI manager shows first of all the anxiety rating slider thing. Once we've entered a rating on that, the UI manager then sends the score to the scene manager, and the scene manager then sends that to the game manager, which then sends that into our save game file. Once the scene manager has sent that off to the game manager, it can then play the next level. So the scene manager in this case is a spider scene manager, and the spider scene manager has all of the levels. The spider scene manager then deactivates level 9 and activates level 10, and then level 10 has whatever new kind of spider object we have here. Sitting with that, I feel like Charlie in that episode of Always Sunny, where he's like really hopped up in coffee and working in that mailroom, and he's got that big diagram behind him and he's all crazy. That whole meme. But yeah, hopefully that gives some kind of an idea of the flow of data through the system as a whole, and hopefully that architecture seems at least semi-coherent. Something else, this little thing that I've changed, is just sorting out the naming conventions. So for example, before we had like manager and controller being used pretty much interchangeably. Now I'm saying that something is a controller when it does some actual decision making and has some actual logic going on, and it's a manager if all it's really doing is just aggregating components, or if it's just pulling data from the scene. So say this border manager here just holds references to the border game objects and just basically stores what their like X and Z positions are. Doesn't really do any logic, doesn't do any decision making, but it just passes data about game objects in the scene to the path controller. So yeah, that's pretty much all I have for you all today. It's really challenging to do these kinds of more technical videos in this kind of a format when there's no, like normally at work when I'd be walking someone through this, it's a two-way process, right? You'd have someone that can actually ask questions and get clarifications and stuff, or at least nod along to confirm that you don't sound like a complete madman, which we obviously don't have here. Please ask any questions in the comments and stuff, but it makes it challenging to not have that direct two-way interaction going on. So hopefully this went okay and it makes some semblance of sense. Okay, so next episode, now that all of this is done, we can actually start making improvements, fixing bugs, and adding new functionality to our spiders properly. So this has enabled some new feature work for the next couple of updates, which is exciting. So yeah, hopefully we can get back to the more exciting, glamorous work next update. All right, thanks a lot for watching, guys. See you next time.